What?
You do number 19.
Yes, I would be happy to. Okay, so now put it somewhere put it on my desk in front of my chair so during my planning, get whatever photo pin really big on it. All right, 19. Yes, you can leave an I in the problem. You don't want to leave an I squared or an I to the 4. How many times, what's the remainder? 49 divided by the remainder of 1. Should just be I.
Wait, so we're going to be I, like, it wouldn't be like square root of negative.
Just be I.
That's what
All right, number 19, negative 4x squared minus 3 equals 481. What? Oh, yes, I thought you were saying I wrote it wrong. I was like, no, it's definitely minus. My apologies. Add 3 to both sides, you're exactly right. I have negative 4x squared equals 484 divided by negative 4, yes? Yes. Negative 121.
Mm-hmm. And that's I.
That's why I was confused for a minute, Miguel. Are you on calculus board?
I think so.
Okay, see if that works now. A what?
Earworm, what's that?
The worm in your ear.
Did it work? Okay. Sure. Okay. Number 7. The square root of negative 8 times the square root of 24. What is 8 times 24?
Math.
8 times 24, wait, what? Negative 197.
Thank you. Take the I, take the negative out. Square root of 192.
12 and 16.
12 and 16. So, oh, even bigger.
64 and 3.
So I do.
64 and 3. Well, you can solve them within that 12. You can break down again. So 16 and 3. So plus or
4
minus.
and 3.
Oh, sorry.
No problem.
7. Jeez, I can't get it together today. 64 and 3. Okay, so did you do it the way Sullivan did it?
I got the same thing.
That's fine. Even if you don't pick the biggest one to start with, as long as you keep breaking down, you're good to go.
What was the answer to the problem that you did? The 19? Or did you not do it?
Yeah, 11I.
Thank you. Oh my gosh.
What'd you do? Or if I have it.
Oh, I added wrong. Are you kidding me?
You broke down each one individually first. That is okay. Did you eventually combine them once you got down? Okay, yes, that's fine. Did y'all hear that question? You don't have to necessarily combine them in the first step. You can break each one down individually and then combine once you get down. Or you can combine and then break down. However you want to go about that is A-okay. So if you break down 8 and 24 to start with, 4 and 2, 4 and 6, and then put the 2 and the 6 together. Thank you, Slay. All right, what else on your homework?
Oh, we can do number 6.
Oh, I bet I can.
I have a quick one. I don't know why. I think I got it.
I've got the square root of negative 288. I go ahead and pull out the I every time just because. What What'd you say?
144. 2 and 144.
16 and 18?
Or
Bigger.
2 and 144.
I'm tired of going bigger.
2 and 144. Okay, but Sullivan, if you didn't take the biggest one, that's okay, because then you just break it down again at the end. You should come back to what we get here, which is 12I root 2. Is that what you got?
I got 6.
Okay, well, let's break it down the way you did. What did you use for 288?
16 and 18.
So that's 4 root 18. 18 can be broken down again, right? What and what? 9 and 2. 9 and
Oh,
2.
2 times 3 is 12.
Indeed it is. And you got that I. Don't forget the I. What else? What else? What else? What else? Okay. 2. That's the old Alpha Center number.
Can I call it?
No, it's not you. What's question 2?
Just screaming out, like, keep square root of the negative.
Yes, yes. Alright, what else?
Do call it?
No.
No, don't. Going once. So we're all ready for a homework quiz on this?
What?
Twice.
No.
On this.
The homework quiz?
No.
Not today because we didn't finish the lesson, but it's supposed to be. It's probably tomorrow. 13, 14. 2I to the 5th times I to the times square root of 6 to the 2nd power. By the way, your last quiz left off factor and solve, right? We did. So your next quiz will pick up square roots, imaginary and complex. Which essentially you're still doing square roots here, so. All right, 2I to the 5th. 2 to the 5th, I to the 5th, I to the 2nd. What is square root of 6 squared?
6.
2, 4, 8, 16, 32. I to the 7th times 6. 32 times 6 is 192. Is that right? Somebody check my math behind me. I to the 7th, 4 goes into 7 one time with how many left over? 3 was the 3rd iteration of I. Negative I. So if I multiply this by negative I, this becomes negative 192 I. F.
Square root of negative 25.
5I.
Square root of negative 15.
I times the square root of 15.
Square root of negative 224.
I don't know that off the top of my head.
Wait, so
I think it's 18.
square root of negative
Is it?
15 isn't
Yeah,
just
it's
15.
Look at me go. Say again?
The square root of negative 15 isn't just
Plus or minus I times the square root of 15. Leave the rest alone.
Square root of negative 44.
2I times the square root of 11. Plus or minus 2I times the square root of 11. Yes, it is. All right. Let's switch gears to notes.
Don't say it. Don't say it.
I'm not.
No.
This is half of a lesson. We're not going to jump into tomorrow's today.
Yeah, this is what we were supposed to get in yesterday, right?
Yeah. I will tell you. Did you? Wait, I might have said that after you left. You know you're leaving early again today. What time are you leaving? What time do we get out of school?
9:55.
What? Oh.
Oh, we jump here, Tony.
Quiet.
Alright, take it on.
Okay, yes, sir.
11:20. We got 11:20. Well, we wasted our lot of time already. I think we're.
That went from 2 to 5, you need to make it
I
0.
checked that. No, I checked
Okay, here we go. Here we go. What is a complex number?
I don't know. What is a complex number?
It's not as hard to think. It is complex. It is. But it's really not bad. It's made up of 2 parts. It has a real number part. A real number is exactly what you are used to. And then to the real number, we either say plus or minus some imaginary value. So, an example of a complex number might be 2 plus 7i. That is a complex number. It has a real number part, has an imaginary number part. In standard form, this is exactly the way we write it. We put the real number first, the imaginary number comes second. Okay? 10 minus 4i. Again, complex number. Not a hard concept there, right? Everybody okay?
Not really, I'm writing.
Okay.
So it's just like,
No, it determines whether or not it has a square root of a negative 1.
can you say that like briefly, real quick?
It has a regular old number, and to that regular old number, you add or subtract an imaginary number. That's complex number.
You should explain everything to us, like, since we were cavemen.
I just did.
A regular old number would be like
Yeah, it'd be a lot
5,
simpler.
6,
Add
8,
four.
4,
That's a regular old number.
1,000.
Yes, Sullivan, yes.
Well, what about 2.5?
Still a real number, so it would still work.
So,
All
Doesn't have to be a whole
all
number.
numbers are real. All numbers are real except for I and -0.
There is no negative 0.
Exactly, that's why it's not real.
Oh my gosh.
tell her not real.
Let's talk, here we go. Let's talk about operations with complex numbers. Now that you know what a complex number is, we're going to talk about addition, subtraction, multiplication, and yes, division. Y'all are not with me this morning.
Yeah, I think we need brain breaks.
Okay, you haven't used your brain yet.
Hey. This is pretty complex.
Yeah.
Touche. In the middle of the lesson. Okay,
I don't think we have.
addition first. Whoa, I think we lost the wheels. Addition, remember I'm talking about not imaginary, but I'm talking about complex numbers. This is going to seem so basic, you're going to go, oh my gosh. Let's say I have, Sullivan, give me a complex number.
-3.
Oh, keep going.
-3i. 0.5.
-3.
That's the real number. Thank you. That's one. Why?
Come on, Sullivan.
Miguel, give me another complex number.
5 minus 2i.
Nice. To add these together, if you
I
would.
have a better one.
Okay, too late. Come up with a better one next time. Addition, all I'm going to do essentially is combine like terms. That's it. I'm going to combine the regular old numbers and I'm going to combine the imaginary numbers. And together they're going to give me a complex number. In this case, I have -3 and 5, which would give me what? 2. I have 4i and -2i, which would give me easy. That's the answer.
These are easy.
Until we get to division.
That was so hard. I didn't know during verse.
If it's plus 2i, would it be?
Is that it?
Yeah. No, don't square it until we start multiplying.
What?
Okay, that was the addition, that's it?
That's it.
Okay, alright, let's just stay on.
Subtraction's going to be almost as easy. That's it. That's it. Don't make it anything that it's not. Combine like terms. Okay, subtraction. Dozier, give me a complex number.
Can I?
-3 minus 4i.
Sully, didn't do so well with the
I'm gonna
first
do,
one.
I'm gonna do the
Okay, give me one.
Oh, minus -6 plus 8i.
There you go.
We call down the office and do my pick up my break.
There we go.
Cut that movie off!
It's not a movie!
We need to take away his camera.
Alright, subtraction.
I'm not even paying.
Here's the only thing that I have to tell you, is make sure you understand you're subtracting everything that follows the subtraction sign, okay? I'm not just subtracting the -6, but I'm also subtracting the 8i. So some of you might have learned this as like a distribute -1 kind of thing when you're subtracting. I don't know how you learned it. I just subtract them. Subtract everything that follows the minus, and I'm still looking at like terms. If you're a same change kind of person when you subtract, then you have to change the signs of everything in the second parentheses. Okay? Okay, well let's just look. Let's look at the like terms, right? -3 minus -6. +3. Everybody okay with that?
Got it.
-4i, again, minus 8i.
Oh, -12.
You have to subtract everything, but that's it. That's all subtraction is. Almost as easy as addition. Are we all on the same page? Let's multiply. Bravo! It's not bad.
It's terrible.
It's not terrible either. I know which one. I want to do this one.
We're going to distribute.
Oh, yeah.
And remember, I squared equals what?
-1.
There you go. Yeah. All right.
I'll do this one.
Division's the hardest.
I'll do this one.
I'll post the recording, and I'll post the notes. I'll have the notes for this one. You want to do another one? Okay, Miguel, give me one.
6 plus 9, 9.
You really got like that.
Yes! Yes! Yes, I had to.
You had to
No,
lie.
you did not.
Yes!
Thank you.
No,
All right, this is a FOIL type problem. I said distribute because I can do this with imaginary numbers. I can put an imaginary outside, whatever. So I'm just going to say distribute. But because this is two binomials, I'm really foiling is what I'm doing. So 6 times -7. -42. 6 times 2i. Now I'm done with that one. Now I'm going to distribute this one through. 9i times -7. And 9i times 2i. There you go. When we get here, clean it up. Combine your like terms. Drop your I squareds. Make it nice and neat. You should just have a complex number when you finish. You might have a real number. You might have an imaginary number. But you shouldn't have all of this. I have, and this is where I get a little bit lazy. I go ahead here without rewriting the whole problem and go, well, I know that that equals what? I squared is -1. So what is 18i squared? -18. I squared only, it drops off and changes the sign of the number, right? So now I have, remember I want my real numbers first. -42 and -18 give me what? 12i and -63i. Nope. If you ever see an I squared, you drop it off completely. completely and you change the sign of the number. Every time. Questions about that one? How about this one and then we'll do division? Give me a complex number. Yeah, that's probably for Wyatt. Say again?
No, either.
Anybody? It doesn't matter. Give me
3
one.
minus 6i. Alright, sounds good.
Give me another one.
That's right,
There you go.
Can Andy come with me? Andy's partner. Just with you. I need a partner.
Is that the
Yeah, or minus 8i. Give me one more. Oh my gracious.
Were you doing multiplication minus?
Where's
Okay, so that's good. I'll send them. What did Thompson for Christmas?
Oh, he's gone.
Were you wearing? Here you go.
Okay, Hunter, give me another complex number.
4.
Wait, what is this?
4 plus 16. Y'all, where'd my thing go?
Is this a trap?
Where's my pencil? That's calculus. Yay! Okay, Hunter, I'm really sorry. Tell me again what you said. Lots of 8s here. Okay, order of operations take over here, yes? I've got multiplication and I've got subtraction. What comes first? Multiplication. I'm going to multiply the two complex numbers first, which is a FOIL type problem, right? 3 times negative 8, negative 24. 3 times negative 8i, negative 6i times negative 8, and negative 6i times negative 8i. I'm going to clean this up before I subtract the second one from it, okay? So I have, this becomes, what's this 48i squared become? Negative 48. Now I have negative 24 and negative 48, which would be negative, there you go, negative 24 and 48 i's plus 24i. Now I can subtract 4 plus 8i. Boom. Negative 72 minus 4. 24i minus 8i, and we're done. What time do we get out of here today? Okay. Yeah. It's late start today.
Late start.
I know that's schedule's wrong.
It's right.
I'm pretty sure 11:45. But there's
11:20. Okay, let me run through division and I'll be done. There are 2 scenarios with division. One easy. We didn't talk about operations with I because they're pretty self-explanatory. But here I'm going to take just a minute and talk about operations, or talk about division with I. So I'm going to talk about 2 different situations. One, I divide by an imaginary number. And situation 2 is going to be I divide by a complex number. And these are going to have 2 different ways that we solve. What is the difference in an imaginary number and a complex number? the real part. An imaginary number is just something I. Okay, that tells me it's imaginary. So be able to recognize the difference. Now, if I divide by an imaginary number, let's say I have 5 over 2i. Why is this a problem? There's a square root in the bottom. And when there's a square root in the bottom, how do I get rid of it?
You do.
Multiply it by that square root. So if you have an I in the bottom, all you're going to do, multiply top and bottom by, and I'm just going to do it by I. I don't need to do it by 2i. I only need to do it by I. The 2 is not under a radical. It's not causing me any issues, only the I. So if I multiply top and bottom by I here, times I, that's really like multiplying top and bottom by square root of negative 1. Over, you're exactly right. So now I have 2i squared, and we all know that 2i squared simply becomes negative 2. So this simplifies to 5i over 2 and the whole fraction is negative. Or you can put 5i over negative 2. Doesn't matter. Yes, that's the answer. Dividing by imaginary is easy. Dividing by a complex, slightly more difficult. Yeah. Yeah. Another imaginary.
When the number on the bottom becomes negative, you have to write the whole fraction as negative, or can you just write it?
Either or. Either or. Did y'all get it? Top and bottom by I. I get, this is 3i squared, which I know is going to be negative 3. I get 7i over 3. You can do 7i over negative 3. You can do negative 7i over 3. Either of those will work. Okay, let's talk about dividing by a complex, because here's the hardest part. Now, have you all heard of a conjugate before? Okay, but not in math. A conjugate has to do whenever I'm talking about square roots, okay? If I have something like 2 plus the square root of 3, okay? The conjugate of 2 plus the square root of 3 would be 2 minus the square root of 3. It simply changes the middle sign. And these are very important because when you multiply conjugates together, the radicals end up going away. Okay? If I were to FOIL this out, and I'm going to just do this quickly just to show you, you don't have to write this. Minus 2 root 3 plus 2 root 3 minus 3. Look what happens in the middle there. I'm just left with a real number. Okay? So I'm going to use this concept, but instead of just conjugates, I'm going to talk about complex conjugates. Because remember, that complex number is really just, or that imaginary number is really just a radical, right? It's just the square root of negative 1. So I'm talking about radical conjugates here also. So if this was 2 plus 3i, what would you say the conjugate is there? 2 minus 3i. How about negative 4 minus 7i? What's the conjugate? And I know that sounds really easy, but I need you to understand we're not changing both signs. We're only changing the middle sign when we do this. Okay? Now, when you multiply complex conjugates together, you get a real number. No imaginary, just real.
On your first conjugate, example, how'd you get the 4 and then the 3?
I foiled it out.
Oh,
2 times 2 and then root 3 times root 3. So let me show you how we're going to use this. This is a problem. Did y'all get all this side? This is a problem because I have an I in the denominator, and an I in the denominator essentially means I have a radical in the denominator. So to get rid of it, I'm going to multiply. This is where it gets wordy. I'm going to multiply the top and bottom by which conjugate? By the conjugate of the denominator. I'm going to put bottom so you know what. Okay, because remember, I can have an I up top, I can't have an I in the bottom. This just leads me to a lot of work, is what this leads me to. It leads me to a lot of foiling and multiplying, but it'll get rid of the I's in the bottom. I told you this was the hardest one. Top and bottom by the conjugate. So what am I multiplying the top and the bottom by here? Oh. Sorry, I know we're going a little bit faster here. I just don't want to go on catches. See why we didn't have time to throw this in yesterday? Now it becomes a problem just like we did when we multiplied. Do it separately if you need to come off to the side and do it separately. Multiply the top by foiling. And you might not have a complex in the top. You might have a regular old number in the top. I just started with the hardest because I want to make sure I got through it. 5 times 3 is
15.
5 times 2i. 2i times 3. 2i times 2i. 4i squared. On the bottom now. This is where the magic should happen. I shouldn't have any i's in the bottom once I get it simplified. 3 times 3. 3 times 2i. Negative 2i times 3. That's right. Negative 2i times 2i. Squared. Okay? Magic. Up top, I'm going to go and change all my I squareds. I do that. That's the very first thing I do whenever I multiply things out. And I go, well, wait, this becomes negative 4. What does this one become? Positive 4. The 6 i's in the bottom cancel. That's exactly right. So up top, real number, what do I have? 11 plus 16i. That's exactly right. Over 13. Now I'm done. There's no i's in the bottom, so I'm A-okay. Tell me what you think.
How do you
Okay, good.
How do you get rid of that? Yeah, your square.
How do I get rid of which squared?
Just change the number next.
Oh, okay.
Yep, I squared just changes the sign of the number, that's it.
How far so good?
Ooh, we finished.
You missed a lot.
Yay!
You missed a lot. You're gonna be so behind.
That's great face.
Where is your
Yeah, they need a great
break?
break.
Okay.
We had 3 minutes.
So tonight, what you're